Welcome to another GCBASIC deep dive. This is part 3 of the challenges I'm going through to get the Q24 chip family working. So this one is about what I call the PPS challenge. So I'm going to be quite honest with you on what's been going on for the last 4 years, and this will give you some insights to some of the challenges that we sort of resolve and people leverage and take and use across other compilers. But I should be honest, and we'll make it quite clear. Right, okay, look, I've been doing some videos. I'm down to the 8th video, and I've now got to address PPS. Up to now, peripheral support through using the PPS has not been required. And I now need to make it work. And as I work through these videos, other challenges come up. And clearly, serial usage is the next, and you need to get PPS working. How you get PPS working is the challenge. Okay, let's just look up open source compiler supporting the Q24 and its common code. So, but there's nothing common about PPS. PPS was implemented by Microchip. To my memory, it was introduced on the 32s, but in the 8-bit world, it came in about in the PIC 16F 1855 range, that sort of chip family range memory. You might correct me in the comments, but about that sort of time. And now everything needs PPS. So we've seen this diagram before, how we take things, but PPS doesn't show up on any of this because it's in like a tool chain that we've got, and in that tool chain there are many different things, and one of them happens to be PPS, and it just doesn't show up on this diagram, but it's one of the chip constraint things, one of the red things that says you've got to get it working. We could actually just ignore PPS and just leave the users to it, but that would break one of the principles of GCBASIC that Hugh put down that says basically don't make it hard for users, and PPS is the answer, and PPSTOOL was the answer. So what have I got in terms of hardware? I've got a prototype board, blah blah blah. Let me just show you what I've got. I can talk you through it. There's no power on it. Let me put some power on it. Where's the power cable? Is it on the floor? Yeah, I was doing some other work. So I've got a chip up there. That's the chip there. I've got PitKit 2. I've been using PitKit 3, some LEDs and some other stuff going on. Doesn't really matter what's going on in reality. PitKit 2 is connected through here. What I've got on my lab, you can't see it, through this yellow cable here, which is tucked up behind this cable. You can't quite work this out. Oh, there you go. Cool. Yellow cable connected into a particular port, and I want my serial to come out on C.6, which is tucked up behind this red cable here. Okay, and there's a reason for that red cable, which I might also cover. Okay, so look, all I want to do is get some serial out of there. That's all I want to do. It's quite simple. PPS is the answer. Go back to my PowerPoint. So what I'm going to do is try to get the UR to show the ADC result on the terminal. So let's get some code up. Let's go straight into some code. I have some code operational here. Let me just get rid of all that. Control R. I'll bring up first sample, and I'm just going to go Control B to empty out the code. I've got nothing in there now. Okay. So here we got some code. I am just going to what's in here? Oh, this is blinking. Oh, let me have a look. Here we go. All the way to the bottom, delete, back to the top. So I'm now in the, I'm in the editor, there we go, hash chip. What is this chip? 18 F26Q24. Great. Option explicit. And all we have to do, oh, I'm so sorry. Because I wasn't looking at the screen, actually. I was looking over my shoulder. Option explicit. All I need to do is add in the serial stuff and we'll be operational, won't we? So let's see how we do that. Historically, we go function key F4, bring up PPSTOOL. Now, PPSTOOL was written by Pete Everett many years ago, and it was based upon a set of XML files that Microsoft used to use. And halfway through, they changed. So we have a bit of a problem. I'll show you that problem. If I come into here and I show you the list in here, 16, 24, 26, 26, 26, K24. Now it's there. Let me show you what I've done, because there's no other K24s in there. Look, there's no other Q24s. There should be a 27 Q24. No, that doesn't exist. Trust me, there's no other K24s in there because I have literally hacked this together. So if I show you what I've done, it's a hack. And this hack was going on and it has been going on for quite a while, because when Microchip stopped producing the XML files, they moved over to a different IDE. Let me show you the whole problem. MPLAB. I'm going to open up MPLAB 6.20. That would be a great MPLAB 6.2. Okay, it's going to take a moment to load. I'm going to load in a chip, and that chip I'm going to select is going to be the old 18F. It's quite a good, interesting chip, because it was clearly at the beginning of PPS implementation when Microchip had one technique in their IDE to show you the user interface, and then they changed it to a second one, which some of you have seen, some of you haven't seen. But the problem is when they transferred to the second option, they didn't maintain the old XML files, which leaves people like us just hung dry in terms of what we can do. So this is the IDE. It's sort of settling down, I think. Is it settled down? Has it sort of finished? I'm not sure. No, it hasn't. There you go. There we go. So I think it's settling down. We'll let it sort of settle. There we go. Hopefully it's settled down. No, it hasn't settled down. It's passing the older projects. And it's got a load of empty icons in here. I mean, this machine is fast. Right, here we go. New project. This is I mean, I should have pre-started this, to be honest, but it does show you some of the slowness in using the application. Right, so UI might be slightly different for if you're using previous versions of MPLAB, but essentially I'm going to create a project, and that project's going to be a 16F188. I'm showing you this because you can then see both of the options, okay? I will select that one, fine. Look, I have got a PitKit 4 attached, not really bothered about that. I'll use the latest compiler. I'm going to put project name of 16F1885, enter, and it's just going to put the whole thing in, and it will automatically, this version of 6.2, for some reason, opens up the MCC automatically on finish. That's because, to be quite frank, most people had no idea what to do in the older versions. It just sat there. I mean, it was worse than GCBASIC, to be quite frank. Okay. Now it's going to load MCC. Now I haven't done this, but I think it's going to give me two options for the MCC, and that will sort of prove my point. So it's preloading the MCC, and it's going to pick up two ways of doing MCC with this older chip. Older chip, it's like 4 years old, okay? So it's opening up the content manager. Okay, it says Melody is next generation, so the only one, oh, wait a minute. So it says now, which is, oh, look at this, very careful, look, be very careful. This is MCC Melody, which is the newer version, but if you want the classic content, classic being less than 4 years old, I'm sorry, that really should say the previous release, click here. Ah, classic is not maintained actively. Next, that's because they just dumped it halfway through. And they sort of changed over to Melody, and this is the older one that some people may recognize. I don't know, but this uses the XML files, and those XML files were great. We then picked those up, and we picked them up, and we came into here, and we went, Okay, I want some UART plus UART added in. Which UART do I enable? The UART is a little thing at the top here, look. And here's my pins down here, look, my pin manager, and it says in here I want to use pins 6 and 7, and I would go in the olden days. Oh, thanks, guys. The help's come up. Generate, and it would generate a set of PPS files for that particular compiler. Fantastic. But what I did, I spotted it was using the XML files. I spoke to Pete Everett. Pete Everett wrote a tool called PPSTOOL based upon the XML files. But Microchip just stopped using this particular user interface. They moved over to Melody, don't maintain it anymore. So that means that we're sitting on an old set of PPS files. But it doesn't really matter because there are other ways of doing this, but they're just a bit of a pain. PPSTOOL is very quick. You get in there, you select your chip, select your stuff, job done. I'll show you PPSTOOL. Back into our IDE, function key F4, PPSTOOL. It will open it up. It opens up a whole series of XML files, which were lifted in the old days directly from MPLAB. Can't do that anymore. I'll show you how I do it in a minute. Go into here, you go, right, I want TX1 on RC6, add, copy, paste that into there, job done. You've now set up the PPS, add in the USART defaults like that. And that would do me. I meant to put a baud rate in there. There you go, baud rate. I'll put a do loop in here. H serial send character A and wait 100 milliseconds. You can't quite see it on the screen. I know you can't. Function key F5 and it will program that. Hopefully. I was doing some other work. There you go. Now, what I just did, I used PPS to shove in the right PPS code for that particular chip. Here's a serial terminal. You can see I've been doing other work. Disconnect, reconnect to that. Oh, look, the letter A is coming up. So that tells me it's sort of working, okay? I don't really care. It's working, all right? Hello world, okay? There you go, just to prove it works, because some people will say I'm not being truthful. Okay, so what I'm telling you is that PPSTOOL, whilst it looks like it's working, I copied an existing XML file, which, there you go, hello world. I've copied a file. I just took a file that looked like the right one for the Q24, the current chip, and it sort of works. And what I'm going to do is I'm going to hack it so it does work. So in here, this is my installation of PPSTOOL, GC Studio, PPSTOOL devices, and here is a description file. It is the XML file that was used in the previous version of MCC, same format. If I put that in here, drop it in there, it says it was for a 26 Q27. Because the only thing that is used inside of this massive file is the PPS. Pete's tool only reads the PPS. It doesn't validate the file that the internal name is 26Q27. Doesn't do any of that validation, never has. All it does is shows you the PPS. So essentially what it's doing is the file is opening up. If I open, I should do it inside of here, be quicker. Pick info. It's opening up pick info for us. Essentially what it's doing is it's Q26, get the data sheet. I'm going to open up the data sheet. Here's the data sheet opened. Great. All right, that tool's even better than the Microchip one, to be honest. Right, PPS is in here somewhere. Where is it? PPS, PPS. Anyone see PPS? Peripheral select module. There we go. Look. And there's a table. And this table, we would find this table inside of that XML file, but we won't because not all the pieces are there. I'll pull up the one, pick 18F 26 Q71 datasheet. I'm going to open up that datasheet and put it next to the one that we're working on. Come on. That's that one. That's the Q24 on the left and the Q71 on the right. Good. Come down to here. PPS. As you can tell, I'm trying to find it. I just can't see it. Got it. PPS, there's a table in here. Now that table looks pretty similar. Interrupt 0, and I will go through all these different PPS selections. Oh, you can't quite see it on your screen, can you? Let me just pull that across. There you go. I will go through and marry those two up and make sure that the XML just for the PPS section is correct. And I'll do it manually, he says. In reality, I have written, if you look inside the installation, in reality, there's a set of scripts in here, all written in a text processing language called awk, which is like C. And essentially what it will do, it will actually go through, it will edit out, and it will change all those things for me automatically. So I have to do this every time because we don't have a data source anymore. But once it's done, it's done. Anyone on the planet can then pick up those XML files, claim that they're a genius, right? Yeah, and they're really friendly to the world. Okay, and PPS works. The reality is somebody near London in the UK has sat down and worked the differences between these sets of data sheets. Okay, so I've worked out what the differences are, and there's two tables got to be gone through. There's this table here, table 22 in one, and then there's the actual pin assignments on the next table. And I go through and I marry the two up. Okay, because if you look in here on the Q24, look at the Q27 on the right, it stops at 28 hex, and clearly 28 hex is down here, is a completely different output source. All that will be sorted out, and I'll just go through. It will just take me 4 or 5 hours. I'll just go through and marry the whole thing up in the XML, and I'll literally type in the XML by hand. Why? Because Microchip dumped one method. Now, we have a choice. We could implement the PPS tool based upon all the melody inputs. Oh yeah, Pete's going to do that, isn't he? Yeah, and I'm not going to do it because we're hardly likely to see many more 8-bit picks. So with the demise of the 8-bit picks, I mean the Q24s, it's like one of the last ones I've seen. If there's more coming, Microchip, do tell me, because then we'd put the investment in. But you can see that this PPS, which seems to be working inside of GCBASIC using not pick info, but using PPS tool, it seems to work. It doesn't, because at the moment I've taken the Q71 just to get me working. Now, how did I know the Q71 would work? Because typically the UART assignment is the same assignment for the same type of chip. Let's have a look at that. So in here, in that list lot, on the right hand one, you can see, let me just bring that up. On the right hand spread data sheet, 015 is the output source for UXR1TX. On the right hand one, 115 is exactly the same. You can just about make it out, and I'll try to level those up so you can see them both. Oh, they're about the same sort of level on the screen there. But essentially what you've got is the same number, and it happened to be the same number. I just happened to pick the Q71 as a random chip, basically. And lots of the things are the same, but many of them are not. As they get towards the 30s and the greater capabilities, they diverge. So for the demonstration that I'm doing, guess what? I've got a PPS tool. In reality, it's broken. It doesn't work. And by the time I'll get to someone complaining, I will have gone through and fixed it for the 40 pin, the 48 pin, the 40 pin, the 28 pin, etc. pins. Because there's lots of XML files to be fixed and all the different chip ranges in the Q24. All that gets done in the background. No one ever asks what happens. Magic happened. And I was doing that magic in the background. And that's me being honest. It's not easy, but I wrote a set of scripts to sort of help me along, and I take these tables into text editors and I sort of munge them all together, and it sort of works. And it's a quicker way than me having it typed by hand. So in the program, let's go back to my PowerPoint. What I'm trying to do, if you remember, is get the serial values to display on the screen. Let's go back to my code. Where was I? I got quite a bit open. First sample. We know that with this hacked up PPS tool, I can insert it into here. And I am extremely happy if someone says to me, we don't need PPS tool, we should dump that and we can all do it by hand. I don't believe them. The novice user would never get past PPS. They would have to be forced into a different language. Now, I am aware that other compilers use PPS tool, so why don't you join the party and do some work and help me here? Okay, this is not free. You are taking tools from GCBASIC and using them without doing the actual work. So if you want to come along and do the Q24 series, absolutely, I'll drop and let you help me. Okay. Now, in my demonstration, I have got a program called Reversible, and I've taken the hacked up version of PPS tool, and I've inserted my code into here. And if I press function key F5, as in the next demonstration I shall be recording, I won't be mentioning all of the stuff that I've just told you about the problems in the tools. It would just be a nice, sweet look what works in Great Cal Basic, okay, or GC Basic. All right, look, there you go. Look, I just so that you can see it all, I will go out to Zen mode. This is what I'll be showing them. Oh, look, as I rotate this, look, I get a representation on the terminal. And if I push the button, it reverses direction. And the LEDs reverse direction. Look at that. I mean, that is cool code, all right? PPS tool, written by Pete Everett. Thank you very much. Don't thank you very much, Microchip, because you've left us sort of in the lurch. You don't give us any source files, so we have to create our own source files. And this is worse than the DAT files we have to generate. But it works. And we have a way around it, and everyone else can share the goodness when I release it, okay? As you can tell, I'm a little bit hacked off about this one, okay? Good. So my goal was to show you the ADC. So in here, I'm going to come into here. I'm just going to update my little PowerPoint I'm running along with. Issues noted. So yeah. PPS does not work. Okay, it doesn't work. It doesn't work. Okay, is not supported. That's a better way. PPS tool does not support Q24 chip family. Edit. Well, it's actually edit existing XMLs to represent this new family. I haven't done that yet. I'll come and do that in the next few days. I shall make a presentation, and I will have resolved that issue. So I'll move that to the bottom later on. But then the next issue I'm going to hit. Let's have a look in here. The next issue. I will speak about this during the demonstration. Actually, I should have mentioned this. What was that red wire doing? And I'm going to have to bring this up. because this is the domain issue that people are going to have to learn very quickly. This is the VDD for the overall chip. This is the VDD IO2 for the data domain, this green domain. So the way to think of these is that that is a voltage domain. Okay, and you go, what on earth? That's because you can actually use different voltages in there. You could have the chip running at 3 volts and that voltage domain working at 5.0. I've got them both working at 5, doesn't really matter. But let me just show you in Zen mode what happens when you disconnect the voltage. Now we can see that that chip is working. You might not believe me. Let me just wang that about that. There you go. Look, that's definitely working. It's sending out data. Okay. Up the top here, I told you earlier on, there's a voltage domain. This is the voltage domain. This is on C.7 or equivalent to what used to be called C.7. If I unplug that, trust me, that's not GCBASIC. That is the voltage domain being incorrect. Put the voltage domain back in. I will change that voltage domain from 5.0 to 3.3. I can easily do that on my board, and it comes back up. But the moment I disconnect it, if I ground it, what would happen if I ground it? Do you know what? I actually don't know. I don't want to test that. I don't want to test it through in any way. I'll put it back on 5 volts. No domain, 5 volts. That's not a GCBASIC issue. That's because you need to have the right voltage domain power laid on before you start using that port. I have been caught out several times on this Q24 with the voltage domain. Bit of a long video. New chip family, getting the basics, operations, it ain't easy.